I'm Angus Gordon. This presentation summarises the results of studies that I and my colleague Lex Nielsen have undertaken looking at the large-scale impacts of jetties and training walls on the New South Wales coast of Australia. We've been undertaking this work to get a better understanding of the impacts and also to be able to predict future changes. The talk is in two parts, first concentrating on the open coast, the second on some impacts in estuaries. But firstly, why build jetties and training walls in the first place? And generally it's to stabilise entrance locations for estuaries. It's to improve the navigability, particularly over offshore entrance paths. It's to increase the discharge capacity for major floods, and to improve water quality in estuaries by increasing tidal flushing. Let's look at the impacts on the open coastal system to start with. As is fairly well known, jetties tend to trap littoral drift, causing updrift accretion and downdrift erosion, sometimes requiring additional works, such as installing an active bypassing system. Jetties can also change the nearshore wave patterns and thereby cause coastal realignment. In cases where the jetties have caused estuaries to scour, this has jetted sand out of the entrance and into the longshore drift system, thereby sometimes effectively nourishing beaches. Jetties can also improve the surfing opportunities due to the new breaks that form alongside the jetties. I'm going to start by looking at the situation on a littoral drift coast, a net littoral drift coast, and this is Coffs Harbour, which is located about halfway between Sydney and Tweed Heads. That's the Queensland border. On the left, you'll see some blue blobs in the insert. They represent the offshore islands that existed before the harbour was constructed. Prior to the harbour construction, there was a net northerly drift of about 75,000 cubic metres that ran along the shoreline inside the islands. In the mid-1920s, work commenced on building jetties to join the two major islands to the mainland. In the 30s and 40s, an eastern jetty was added to complete the harbour. As a result of blocking the longshore drift, the beach on the southern side accreted and the beaches on the northern side eroded. As the beach on the southern side prograded, sand started to move around the headland and heading around into the harbour. As a result, the harbour has now shoaled to about half the depth it was 100 years ago, and that shoaling is continuing today. A more dramatic impact of jetty construction is here at Brunswick Heads on the Brunswick River, where the construction of twin jetties in the mid-1960s resulted in sand accretion on the southern side and matching erosion on the northern side. As a result of this, by the early 1970s, the village of Sheltering Palms was so exposed that storm waves were able to wash through the village, causing it to have to be abandoned. On an even larger scale, the construction of jetties at the entrance of the Tweed River, which is on the border between the state of New South Wales and that of Queensland, resulted in significant accretion on the southern side, that's the New South Wales side, and erosion on the Queensland beaches. That meant that a large sand bypassing plant had to be constructed in order to transfer the sand from the southern side to the northern side to reinstate the Queensland beaches. But on coastal systems where there isn't a net drift, you can always get coastal realignment due to the changes to wave diffraction and refraction patterns caused by the construction of jetties. Here it's Newcastle, which is a city just north of Sydney on the Hunter River. The view on the left shows what the beach was like prior to construction of any jetties. Construction of the jetties commenced in the early 1800s, and you can see on the right those jetties, and you can also see the original shoreline, which is the green, along with what the current shoreline is. So the jetties changed the diffraction and refraction patterns in such a way that there was accretion against the base of the northern jetty and erosion further round on the coastline to the north. We were able to use this sort of information to look at what might happen if a set of jetties was constructed at the entrance to this lake, which is just north of Sydney. The lake suffers from both water quality issues and flooding issues, but you can see that from that red line that the changes to the diffraction and refraction patterns was likely to produce a situation whereby a substantial number of residential buildings were likely to be lost. So what are the impacts on estuary processes? Well, there are positive impacts, which are to do with the improvement of the hydraulic efficiency and therefore assisting management of floods and the water quality within estuaries. Both the jetties and training walls can stabilise channels and improve navigation. From a negative point of view, however, jetties can produce long-term impacts on tidal planes in estuaries, and that, in fact, I'll cover in a little bit more detail later on. They can also result in channels being scoured to greater depths, and that removes seagrass beds. And on the other side of things, in lakes, the scoured material can be deposited on the flood tide deltas, resulting in the smothering of seagrass beds. But perhaps the most alarming issue is that scouring of these channels can undermine and collapse banks, therefore damaging training walls and other infrastructure and buildings. We started off looking at this issue at Wallace Lakes Inlet, which is at the twin towns of Forster Tuncurry on the coast, halfway between Sydney and Coffs Harbour. Training walls and a jetty were constructed in the late 1800s in an attempt to reduce the amount of sand that was being transported into the entrance. However, as you can see from the bottom left, what actually happened was that the ebb tide ran out along the wall, but the flood tide came in along the beach from the north. That sand movement in the flood tide was enhanced by stirring caused on the bar and in the surf zone by the waves, and so the entrance moved into an unstable shoaling mode. On the right, you'll see what happened in the mid-1960s, 1966, work commenced on extending the southern jetty and building a northern jetty. This completely changed the flow patterns so that they were now directed both in and out across the offshore bar. Interestingly, this resulted in the ebb flow creating standing waves in the channel. The standing waves entrained sediment inside the estuary and moved it offshore. So the estuary moved from an unstable shoaling mode to an unstable scouring mode. We took a look at this issue, particularly where we had a lake connected to the ocean by a channel, and what happened when jetties were built. And what we found was that the jetties tended to cause the channel to begin to scour, move into an unstable scouring mode. Looking at what information was available, we found that the best way of modelling this was using the Escoffier approach. We also found that looking at this Escoffier approach, the unstable scouring mode was likely to continue until it intersected with the O'Brien relationship, which was established when equilibrium was achieved. Taking four systems that were very similar, lake connected to the ocean with channel and then breakwaters, jetties constructed at the entrances. We looked at Wallace lakes, Foster-Tuncurry, Lake Macquarie, Lake Illawarra, which is to the south of Sydney, and Lake Wagga, which is on the far south coast of New South Wales. The solid lines on these diagrams are our predictions. The other points are showing what the actual tidal readings were, and you can see from all four that following construction of the jetties, the tidal planes in the lakes increased and continues to increase. In fact, our work shows that in all four cases, these increases in tidal range in the lakes is likely to continue for more than a century before equilibrium is achieved. Interestingly enough, the result of the additional flushing has meant that we've seen an increase in mangroves, but funnily enough, there's also been a decrease in salt marsh coverage. Further, and here Lake Wagga illustrates the point, the scouring in the channels reduced the amount of seagrass beds, and on the lakeside, some of that scoured material smothered other seagrass beds as it built a new delta into the lake. In fact, over a 20-year period, something like 100 hectares of seagrasses were lost at this particular location. As I mentioned before, scouring of the channels can impact on infrastructure, and here on the channel to Lake Macquarie, we saw the loss of a marina, the associated buildings and a restaurant as the channels scoured and the banks collapsed. At Foster-Tuncurry, where we started our work back in the 1970s, we found that the bridge piers were being undermined and the bridge became unstable, so it became necessary to construct steel caissons driven to bedrock and filled with concrete. These were then joined up to the existing piers and the bridge using large concrete headstocks. Finally, sometimes jetties cause the inexperienced people to assume that an entrance is safe to navigate at all conditions. But as you can see from this, that isn't necessarily the case.